welcome to True Projects. In this video, we are going to explain about the project, which is Standard Latent Space Dimension for Network Intrusion Detection Systems Datasets. Introduction of the project. The widespread adoption of the Internet and the subsequent evolution of communication networks have transformed them into complex, dynamic, and heterogeneous systems, utilizing traditional techniques for designing, deploying, managing, and maintaining these networks has become increasingly challenging. Traditional approaches to network intrusion detection systems face limitations due to the lack of comprehensive research resources. These limitations hinder the achievement of optimal intrusion detection performance. Traditional methods often rely on manually crafted features and that may not effectively adapt to evolving network threats. The project proposes the implementation of a standard latent space dimension achieved through autoencoder-based dimensionality reduction. This approach is intended to overcome the previously mentioned limitations by projecting various network security datasets into this standardized latent space. The project aims to establish a unified and efficient feature representation. The project leverages multiple datasets related to network intrusion detection, which could include CIC IDS 2017, CIC IDS 2018, UNSW NB15, NF UNSW NB15 V2, and NSL KDD. These datasets serves as the foundation for training and assessing machine learning models for intrusion detection. Objective of the project. The primary objective is to enhance the efficiency and the accuracy of network intrusion detection systems by addressing the challenges posed by evolving, complex, and heterogeneous nature of modern communication networks. The project aims to achieve this by introducing a standardized latent space dimension obtained through autoencoder-based dimensionality reduction. The project utilizes autoencoder-based dimensionality reduction algorithms. Autoencoders are the type of artificial neural network used for unsupervised learning. In this context, they are employed to reduce the dimensionality of the input data, creating a standardized latent space presentation. The project aims to use extra-tree and the ANN algorithms to project diverse network security datasets onto a common latent space dimension, thereby addressing the limitations of traditional methods. The objective of incorporating the Flask Web framework with SQLite for user authentication is to facilitate user input for intrusion prediction and enhance the system's usability. Requirements of the project are hardware and software. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this step, the necessary Python packages and libraries are imported, which will be used throughout the project. We have imported NumPy for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for data visualizations, and scikit-learn for machine learning. Exploring the dataset. The project involves the exploration of several datasets including CIC IDS 2017. It is a network intrusion detection dataset that contains network traffic data for various attack scenarios. CIC IDS 2018. It is another network intrusion detection dataset that provides a diverse set of network traffic data. NF UNSW NB15. It is a network traffic dataset that captures network behaviors and includes both normal and attack traffic data. NSL KDD. It is a dataset that is modified version of original KDD Cup 99 dataset and it is used for benchmarking intrusion detection algorithms. UNSW NB15. It is a network security dataset that contains a wide range of network traffic data, including attacks and normal traffic, and it is designed for intrusion detection and network security research. Here we understand all the 5 dataset structure, content, and characteristics. These datasets are used for training and testing machine learning models. Data processing. This phase involves data processing tasks like removing the duplicate data. Duplicate records within the dataset are identified and eliminated. Duplicate data can introduce bias and distort the results of machine learning models. Drop cleaning, which is data cleaning. Data cleaning involves addressing missing values, outliers, or errors in the dataset. This step ensures that the data is accurate and reliable for model training. Visualization using Matplotlib and Seaborn. Data visualization is performed using Seaborn and Matplotlib libraries to gain insights into the datasets and identify patterns or trends. Label encoding using label encoder. Categorical data in the datasets will be encoded into numerical values using techniques like label encoding to make them suitable format for machine learning models. Feature selection. This step involves selecting the relevant features which are attributes from the dataset. The X and Y data are typically defined, where X represents the input features and Y represents target variable. Splitting the data into train and test. The dataset is divided into training and testing sets. The training data is used for building machine learning models, while testing data is reserved for evaluating model performance. Building the models. Machine learning models are constructed for multi-class and binary class problems. Coming to multi-class classification is a machine learning task in which the goal is to classify data points into one of three or more mutually exclusive categories or classes. Using this technique, we have built machine learning models. Extra tree. Extra tree or extremely randomized trees are an ensemble learning method based on decision trees. They construct a forest of decision trees with randomized feature splits and selection, making them robust and less prone. It is chosen for multi-class classification because of its ability to handle a variety of data types and its ensemble nature, which can capture complex decision boundaries in the data. Artificial neural network. Artificial neural networks are a class of deep learning models inspired by the human brain. They consist of interconnected nodes or neurons organized in the layers, allowing them to learn complex patterns from the data. Binary class. Binary class classification is also known as a two-class classification in a machine learning task where the goal is to classify data points into one of two mutually exclusive categories or classes. In this also we have built extra tree and the artificial neural network. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction, and we also have built front-end using Flash framework for user testing with user authentication. Training the model. Machine learning models are trained on training the dataset to learn patterns and relationships between features and the target variables. Flash framework with SQLite for sign-up and sign-in. Flask, a Python web framework, is integrated with SQLite for user authentication, allowing users to sign up and sign in into the system. User gives input. User inputs the data into the system, which is the preprocessed and used in conjunction with the trained models for predicting the dataset. Prediction using trained model. The user's input is preprocessed and the trained machine learning models are applied to predict the desired outcome, displaying the final outcome. The final prediction outcome is displayed to the user, providing insights or decision based on the input data and the machine learning models. Comparison graph for the CIC-IDS 2017 dataset. This is the accuracy graph. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. Here, the x-axis represents accuracy scores of each algorithm and y-axis represents algorithm names. This is the precision score graph. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. Here, x-axis represents precision score and y-axis represents algorithm names. This is the recall score graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances. This also represents recall score of all the algorithms and y-axis represents algorithm names. This is the F1 score graph. F1 score is the harmonic mean of precision recall, offering a balanced measure that considers both false positives and the false negatives, making it suitable for the imbalanced datasets. X-axis represents F1 score of each algorithm and y-axis represents algorithm names. Coming to the comparison graph for the CIC-IDS 2018 dataset, this is the accuracy score graph. This is the precision score, this is the recall score, and this is the F1 score graph. Coming to comparison graphs for UNSW-NB15 dataset, this is the accuracy score for this dataset, and this is precision score graph. This is the recall score, this is the F1 score. Coming to NSL-KDD comparison graph, this is the accuracy score graph for the NSL-KDD dataset. This is the precision score comparison graph for the NSL-KDD dataset. This is the recall score. This is the F1 score. Coming to comparison graph for UNSW NB15 dataset. This is the accuracy score comparison graph for this dataset, which is UNSW NB15. This is precision score graph. This is recall score graph, and this is F1 score graph. Coming to execution. For execution, we need to open the code folder which contains source code file. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different sections of the website. This is the app.py file. This file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, which contain algorithm information and that will be loaded into project code during runtime. Here we have IPYNB files. These are the IPYNB files. This is the Jupyter Notebook files, which contain a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. This is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path from the code folder. So here we are copying the path, and now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This command will change the current directory to the code folder's path. So here we can see that current directory is changed to the code folder's path. So here we need to type command which is python space app.py. This command will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. And now we need to copy this local link provided by the framework and paste it in any browser. So I'm copying this link. I prefer Google Chrome, so I'll paste it in that. So here we'll paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a link which is sign up link. First we need to click on it. Here we need to enter all the registration details if we are signing up newly. I have already signed up, so I have an account in it. So I'm clicking on sign in. Here we need to enter our credentials, which are the username and the password. And now we need to click on sign in. We have signed in successfully. And here we can see that we need to enter all these parameters, and all these parameters are of NSL-KDD dataset which has been trained. By default, we have given link to get the predictions based on the NSL-KDD dataset. If we want to change the dataset, we will get other parameters which are need to be entered. In the predictions link, we can see two datasets which are NSL-KDD and NF-UNSW-NB15. If we click on NF-UNSW-NB15, we will get parameters according to that. So here we can see parameters according to that which need to be entered. So first we will enter NSL-KDD dataset parameters. Let us understand this. Service. This parameter represents the type of network service or a protocol used in network communications. This is flag. It indicates the status or state of network connection such as SYN, ACK or FIN. Source bytes. Source bytes denote the number of data bytes sent from the source in a network connection. Destination bytes. Destination bytes signify the number of data bytes sent to the destination in a network connection. Count. Count represents the number of connections to the same host as the current connection in a specified time frame. Server error rate. Server error rate is the ratio of connections that have SYN errors to the total number of connections. Same service rate. Same service rate indicates the proportion of connections to the same service as the current connection. Different service rate. It represents the proportion of connections to different services as compared to current connection. Destination host server count. It signifies the number of connections to the same service on the destination host. Destination host, same service rate. It is the ratio of connections to the same service on the destination host to the total number of connections to that host. Destination host, different service rate. It represents the ratio of connections to different services on the destination host. Destination host, server error rate. It is the ratio of connections that have SYN errors to the total number of connections to the destination host. Now we will enter all these parameters step by step. So here we will give the service state, which is 47, flag value as 5, source bytes as 0, destination bytes as 0, count as 123, and the server error rate is 1, and this as 0.05. Here we will give 0.07. Destination host server count is 26. Destination host same server rate is 0.01. And destination host different server rate is 0.05. Here we need to give destination host server error rate as 1, and now we need to click on predict. Based on the given input, it is predicted that there is an attack detected and the attack type is DOS. Now we will give another input, which is another set of parameters. I have given all these parameters, and now we need to click on predict. Based on the given parameters, it is predicted that there is an attack detected and the attack type is probe. Now we will give other set of parameters. I have given the input values, and now we will click on predict. So here we can see that there is an attack detected and the attack type is R2L. Now we will give other set of parameters. So here I have given all the parameters, and now we need to click on predict. It is predicted that there is a no attack detected and the attack is normal, which means there is no attack. Now we will select this dataset, which is NF-UNSW-NB15. According to that, we need to give the parameters. So I'm clicking on it. So here, let us understand the parameters. So this is L4 source port. It refers to the source port number at the transport layer of the network protocol stack. This is L4 destination port. L4 destination port denotes the destination port number at the transport layer 4 of the network protocol stack. This is the protocol. It indicates the specific network protocol being used, such as TCP, which is Transmission Control Protocol, and UDP, which is User Datagram Protocol, or ICMP, which is Internet Control Message Protocol. This is L7 Proto, which means L7 protocol. It represents the application layer 7 protocol used in network communications, specifying the application or service being accessed. This is incoming bytes. It signifies the number of incoming data bytes in a network connection. This is the outgoing bytes. It represents the number of outgoing data bytes in a network connection. This is incoming packets. It denotes the count of incoming network packets in a connection. This is outgoing packets. It signifies the count of outgoing network packets in a connection. This is TCP flags. TCP flags refers to control flags used in the TCP header, such as SYN, ACK, FIN, and RST, which provide information about the state and control of the TCP connection. This is flow duration, which represents the duration of a network flow or a connection in milliseconds, indicating how long the connection was active. Now we will enter all these parameters. I have given all these details, and now we need to click on predict. it is predicted that there is an attack detected, and now we will give other set of parameters. I entered all the required parameters and now I need to click on predict. So it is predicted that there is an attack detected, and now we will give other set of parameters. So I have entered all the parameters and now we need to click on predict. So based on the given input, it is predicted that there is no attack detected, and now we need to sign out. The project has successfully implemented a standardized latent space dimension using autoencoder based dimensionality reduction, resulting in significant enhancements in the performance of network intrusion detection systems. This method effectively tackles the traditional limitations of NIDs, including the adaptability to evolving threats and the reliance of manual feature engineering. Machine learning based models trained using the standardized latent space exhibited comparable performance to those trained with non reduced datasets, affirming the viability of this approach. The inclusion of the Flask Web Framework with user authentication improved user engagement and enabled real time intrusion event prediction, elevating the system's usability and the effectiveness.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.